Let's compare three different types of functions. And so this lesson is going to be broken into, well, linear, exponential, and quadratic functions, not necessarily in that order, although we will start with linear. So what we're going to do first is just fill in the table of values and write the equation for the line. And then we'll just have a little bit of a discussion around that and just talk about what that all means for lines, and then we'll do the next one as well in this section before we move on to another piece. Okay, so when my x is -4, my y is, well, I don't know, let's find out. We come over here and we're going to count back to -4 on the x-axis, just in case you forgot. This is the x-axis, this is the y. They're easy to mix up. So what we're going to do is count back 1, 2, 3, -4, and we're going to go down. And when we go down, this is our y value, and it is down here at -5. Okay, we're going to go to -2 on the x-axis. And doing so takes us to here. We're going to go until we see the function, which will be down here, with a y value there at 1, 2, 3, -4. Okay, you may already notice the pattern, but just in case you don't, that's okay. We're going to go to an x value of 0 and see if we can find the function, the line. So there it is, right there. And the y value is, well, 3, -3. We go to an x value of 2. The y value is here at -2. We go to an x value of 4. The y value is -1. And we go to an x value of 6. And the y value is, well, we're sitting on the y value. We didn't have to go up or down, so the y value is 0. Okay, so let's talk about a few obvious things. First of all, it's a line, duh. But if you have a line, there's a special thing about the slope of that line. And the fact is, the slope is constant. And so as I move up here by 2, like I go from -4 to -2. I go from -2 to 0, from 0 to 2, 2 to 4, 4 to 6. As I do that, I'm going up by 2. And every time I go up by 2 on the x, I'm adding 1 to my y value. Okay, so let's think about this. This is a line, and lines follow the equation y equals mx plus b. And so when I do this, I'm going to go kind of old school. You know what m is. It's my slope. And you probably remember that slope, also known as m, is rise over run. And well, rise, those are my vertical values. Those are the y values. And the run is the horizontal. Those are the x values. So when I do this particular problem, every time I rise 1, going from -5 to -4, -4 to -3, -3 to -2. Every time I rise 1, I'm running 2. So my slope is 1/2 times x plus b. Well, b is my y-intercept, in case you forgot what that is. So this m right here is slope. This is the y-intercept. And if you're graphing it, it's really a good place to start, actually. So I would start at my y-intercept. Like if I was to graph this line, I'd be like, there's a good starting point, like right there on the y-axis. And that value is -3. So it's plus -3. You could say, instead of saying plus -3, you could say the real answer is 1/2 x minus 3. Same thing. Adding negative is the same thing as subtracting. We both know that. I do want to point out one other thing here that I've already said, but it is worth repeating for when we get to other types of functions, and here it is. It's this. If I went from -5 to -4, then I'd be adding 1. If I went from -4 to -3, I'd be adding 1. If I went from -3 to -2, I'd be adding 1. And you're like, wow, that's redundant, and I get it already. Please stop. And I hear you. But trust me, this is going to be kind of a neat little mathematical tool that we use in a few minutes when we get to functions that are not linear, and you'll kind of see where this is coming from. All right, let's go to the next one. And as we do, we will notice that it is also linear, and we're going to fill in the tables and write the equation for the line. And so we know that it's going to be y equals mx plus b, and we're looking for our m, we're looking for our b. And you may already know what the m and what the b are. And actually, let's just jump right to it. We know what the y-intercept is. Let's look on the y-axis. It's right there. And there is -1. So final answer is y equals something something x minus 1. So, I mean, we've got a gap to fill in, and we'll fill it in later, but we know that it's y equals something x minus 1, right? Okay, let's fill in the table. We'll go from there. And maybe you know the slope, maybe you don't, but whatever. We'll deal with it. So at negative 2, when x is negative 2, the y value is 1, 2, 3, 4, 5. Okay, 5, cool. When the x value is negative 1, the y value is 2. When the x value is 0, we just figured this out. The y value was negative 1. When the x value is 1, the y value is down here at negative 4. And when the x value is 2, the y value is all the way down here, and down here is 1, 2, 3, 4, 5, 6, 7, negative 7. Okay, so what's our slope? Well, let's do this one a different way. And you could say, you could do what we just did, and we might a little bit. As we go from 5 to 2, we subtracted 3, and we went from 2 to negative 1, we subtracted 3 more, and from negative 1 to negative 4, we subtracted 3. So there's that. And that actually is our slope, but let's look at it a different way. If I wanted to go from one coordinate on this graph to another, like we'll start here, because it's always a good starting point, almost always, and we wanted to go to here, then we could do our little rise over run trick and say, well, I'm going to go rise 3. Oh, I didn't rise 3. I actually went down 3. So my slope, which is rise over run, is actually negative 3 divided by, okay, well, I just went down 3. Now we're going to go to the right 1. And when I go to the right, that means I went positive. So negative 3 divided by 1. So my slope is negative 3 over 1. Anything divided by 1 is itself. So there you go. Now, I want to point out something here, that this negative 3 was the slope, but this positive 1 was not on this previous problem. Sorry, you couldn't see where I was pointing. This positive 1 was not the slope. And the reason it wasn't was because here I was going down 3 on my y as I went up 1 on my x. Here I was going up 1 on my y as I went down 2. Sorry, as I went up 2. So this didn't have a gap of 1 in between them. It had a gap of 2. Okay, so if that didn't make sense, don't panic. The bigger idea is that we can figure out the rise or fall and the run, which could be negative as well, depending on which way we're running, and that will tell us our slope. And also, if we wanted to do that on this first problem, we could say, oh, well, I'd go up 1 and over 2, and there you go. We could rise 1 and run 2. I hope all this is a review to you, so I'm going kind of fast. But basically, I went up 1 over 2 or down 3 over 1, and that's where those fractions came from. All right, again, one more time, I want to point out that this is constant. This first change right here is constant. That's going to be a little bit different when we get to quadratics.